Hi everyone, today we will solve insertion sort algorithm. Insertion sort algorithm repeats the processes of shifting large elements to the right in the array by comparing the element with the previous elements, starting from the second element. Thus, the element that is being lined up at the time will be placed in the opening place. If we add up the work done, first of all, the second element in the array is selected as the starting element and compare it with the preceding element, that is, the one on the left. If the first element is larger than the second element, they are displaced. If not, move on to the next element. The second element is taken into the first index, the first element is taken into the second index, and the third element and the second element are compared in this way. The processes continues until all of the array elements are looked at and the correct sequence is obtained. The beautiful side of this algorithm, for example, according to the bubble sort algorithm, is also checked with all other elements on the left while the elements being sorted is placed. In this way, those on the right have larger elements on the left, and those on the right have a faster ranking with smaller elements. In other words, it does not compare with it on his left every time. If it is smaller than itself on one left, instead of directly switching places with this, it looks at the other elements on the left and enters place suitable for this. 25, 17, 3, 1, 11, 13. Sequence will be sorted. To sort this sequence with the help of the insertion algorithm, the second element of the array is selected as the starting element. 25, 17, 3, 1, 11, 13. Then 17 and 25 are compared. Since 17 is less than 25, 17 is taken to the beginning and 25 ranks second. This is the new version of the series: 17, 25, 3, 1, 11, 13. Now the third element, 3, is controlled by 25, since 3 less than 25, but also 3 less than 17. The number 3 is taken to the top and shifted in order of numbers. The new version of the series would be 3, 17, 25, 1, 11, and 13. In this step, it's time to look at the fourth element, 1. Since 1 is smaller than all of them, they move directly to the left and to the top, and in other numbers, they move to the right and take their own order. The final version of the series will be 1, 3, 17, 25, 11, and 13. The index value to look at in this step is 5. In other words, the element in return is 11. The number 11 is controlled by the 25, 17, 3, and 1 on the left and enters the middle and forms the final form of the sequence as follows: 1, 3, 11, 17, 25, and 13. We can think of this step as the final step. Here 13, which is the sixth index value of the array, is checked. 13 is less than 25 and 13 is less than 17 and 13 greater than 11 are checked and intercepted and take their place in the order of theirs. The final version of the series: 1, 3, 11, 13, 17, and 25. Now we are going to write code for this algorithm. Let's start with array. As you can see, then we create a function called insertion sort. The parameters will be r, and the first thing is, as probably you guessed, is our for loop. I equals to 1 while I is less than array length, and I plus plus. Okay, I equals to 1 because we are going to be going backwards. Okay, Once we found that value, I am going to show it in a second. So let's create that value of array of I. That current, it's going to be our current element. Current equals to array of I. And we need another variable for the inner loop, j equals to I minus 1. Okay. Because if array of I is 3, I minus 1, we need this element to compare it with. So this element needs to be 17, which is I minus 1, because if the I is, for example, 3, we need this element which is 3, which is I minus 1. So here is our variables. And let's create another loop, which is going to be while loop. So the first condition is while array of while j is greater or equals to 0. And here comes our main condition. And our main condition is array of j is greater than current value. So if array of j is greater than our current value, like here in our case, right? So what this condition does, it's checking is 1 greater than 11? No. Is 11 greater than 13? No. Is 25 greater than 17? Yes, it is. And if so, then we are going to put our code here, and then we are going to do what I showed you here, right? So we are going to do this swapping, this shifting to the right, shifting to the right, and it's pretty easy. It's array of j plus is array of j plus 1 is equal to array of j, and we need to not forget to decrement the j, because we will be going backwards. Okay, so pretty much that's what we need to do until the j is small is not greater than current value, for example 3 is not greater than 11, and that means that we stop and we found the correct position to insert our element. And to insert our element, we just say array of j plus 1 equals the current. Array j plus 1 is equal to current. Okay, let's return our array, and let's see if this is working. Let's just call insertion sort, pass it an array, and because this code will modify this function, will modify the original array, and it's going to be sorted. And let's see if it is sorted. Console log array, and let you see that array is sorted. Okay, 1, 3, 11, 13, 17, 25. And yeah, that's the insertion sort. It's pretty fun algorithm, and thanks for watching. Don't forget to subscribe my channel and like my video.